All right, everyone, here is the video key for graphing quadratics in Vertex form. So again, like the other video key hopefully you've watched, which was when we were in intercept form, I've kind of laid out some steps for you here. Removed some of the wording that was in the first one because a lot of it's the same. So I'll repeat it here, but to try to make this a little more pleasing to the eye, hopefully, with less words. Remove some of that stuff, but hopefully at this point you know what most of that is anyways. So first, we're going to find the x value that makes this bubble equal 0, and that is x equals 2. And then you plug that x value in, and that will give you a y value. Like, that's how you always find y values. So if you plug in 2 here, though, you get 0, and 0 squared is 0, and so you'll always just get this number here, and that's always going to be true. So you don't actually have to plug this x value in the future. You should just know that you're going to get the point 2, 1. And so we plot that over here, 2, 1, and that is our vertex right away. So that's our highest or lowest point. We should know, because there's no negative in front of here, that this parabola is actually going to open upward like this. And so this is going to be our lowest point. We're again going to draw the axis of symmetry as a dashed vertical line through the vertex. And we label it x equals 2 in this case. Okay, and that's our axis of symmetry. So any other point we find, we can just reflect it and find another point on the other side. So this is x equals 2 right here. Now we're going to pick an x value that is as close as possible to the vertex. And so, since our vertex is at 2, I'm going to choose either x equals 3 or x equals 1. I'm going to choose 3 because that's going to make the bubble positive, and we tend to make less mistakes with positive numbers. So I'm going to choose x equals 3. So let x equal 3. And then y equals 3 minus 2 squared plus 1. That's just me putting a 3 in right there. So this is just written down here now. 3 minus 2 is 1. 1 squared is 1. 1 plus 1 is 2. So you get equals 2. So now we have another point, which is 3, 2. So let's come back up to our graph. 3, 2 is right here. Using symmetry, there's going to be another point right there. And now we just need 2 more points. So we find 1 more point, and then we can reflect it using symmetry, and that'll be our 5th point. But the point that we're missing that I always want you to find is the y-intercept. And that is when x is 0, and that's what it says right here. So we're going to plug in 0 for x now. And you get, so when x equals 0, we get y equals 0 minus 2 squared plus 1. 0 minus 2 is negative 2. Squared, you have to square the negative, so it comes out positive. 4 plus 1 is 5. So we have the point 0, 5 as our y-intercept. Let's come back up to our graph, plot that point. 0, 5 is right here. You can use symmetry, get another point over there, which is what the rest of that part D tells us to do. And now we can draw a graph through these points. And Notability makes a nice parabola shape for us automatically, which is pretty nice. And so there you go. That's what that graph looks like. Domain is always negative infinity to infinity for every quadratic ever. And our range, so that's domain. Range is lowest y value, which is right here at the vertex, 1, up forever. So it's 1 to infinity for our range. The range always involves either infinity or negative infinity. So you either start at a number and go up forever, or you're coming from the, like, it goes down forever and you stop at a number. And then once again, on this graph, let's see, we have a minimum, and the minimum value is y equals whatever the y value of our vertex is, which is 1. So that's the minimum value. Y equals 1 is the min. Okay, so So here's a few more examples you can do. Again, you'll have access to a handwritten key version of these problems, but you should try these problems on your own, kind of following this problem or following along with the video, hopefully. And you can do these on all by yourself, filling out this information as you go. And you can use Desmos to check once again.